special products. Products being answers to a multiplication problem, right? So we've multiplied binomials, right, using FOIL. Now we're going to find the squares of sums and differences, and we're going to find the product of sums and difference. Okay, so let's see what that's going to look like today. We'll move right along. We have about 15, 16 slides, so I'm going to try and keep it moving. Let me just say this is an example problem where somebody wants to put this thing on a cork board, right? And they need to know how big the cork board has to be. And we know the radius, and they tell us it's r plus 12. Well, there are actually going to be two of those radiuses, right? R plus 12. So that would be 2 times r plus 12. That would give us the diameter. And if we wanted to find the area, right, we would do area times, oh, did I say 2r? Yeah, times the 2r plus 12. 2 times r plus 12, which would be 2r plus 24 squared. So no, that's a basic application about of some of the of something like what we're going to work on today, but don't worry about the details. It's just the idea of where it might be put in place. Okay, squares of sums and differences. Here we go. Some pairs of binomials, such as squares like this one, the one we just talked about, parentheses, the quantity 2r plus 24 squared, have products that, and they follow a very specific pattern that we can look for. And using this pattern can make our life easier. So the square of a sum, and meaning that it's a plus b, right? The square of a sum, the quantity a plus b squared, or, which also means a plus b, right, times a plus b, is one of those kinds of products. So let's look at this in picture form, right? So on this side, we have a plus b. So we have a plus b, right? And we have like as if we were looking at a square where all the sides were the same, okay? And we have a plus b over here. Oops, come back to my square. There we go. We have a plus b on this side, right? And if I wanted to find the area of that, I would be squaring that, okay? So I would have I'd have a squared plus an ab here and an ab here, right? Ab here and an ab here, and I'd have b squared. So if I have a plus b to the power of 2, right, which is a plus b times a plus b, right? That's the same as a times a is a squared, right? And a times b is ab, and b times a is ab, and b times b is b squared. So that would be a squared plus 2ab plus b squared. All right? So if you find the square of a plus b, it's going to be a certain pattern that we're going to see. We're going to have the first term squared, the last term, and the product of the middle terms. Let's look at this in a key concept form here. Let me see if I can make this a little bit larger for you guys. Let me say that again. Okay, so the square of a plus b is the square of a plus twice the product of a and b plus the square of b, okay? So this is what we talked about. We'll have, if we are finding a plus b squared, we'll have a squared, and we'll have the b squared, and we'll have twice the product of a and b right here. So for instance, let's look at an example with numbers. We have x plus 4 squared. We'll have x plus 4 times x plus 4, that means, right? So our x's will be squared. 4 times 4 are 16. Our 4 is squared, which is 16. And we add 4x and another 4x, and we get 8x. Okay? So it's just a pattern that we're seeing. Or you can think of it as twice the product of A and B. Or you can just add them together. All right, let's look at an example problem. Okay, we have 3x plus 5 to the quantity 3x plus 5 to the power of 2, which of course means 3x plus 5 times 3x plus 5. All right, so that's going to be 9x squared, and then I have 5 times 3x is 15x plus another 15x plus 5 times 5, or 25. So our final product is 9x squared plus 30x plus 25. So you can see that we've squared the first terms, squared the last terms, and this middle term, right? This middle term is twice the product of the A and B together. Okay? All right, let's look at another one. Actually, here's a guided practice for you. Go ahead and try these two problems. See how you do. See if you can start seeing the pattern. Initially, it'll feel a little awkward, but then you'll see the pattern. All right? And start it back up when you're done. All right, there's also a pattern for a difference of squares. And or for the square of a difference, excuse me. So meaning if we have a minus b instead of a plus b. Remember, a minus b can be written as a plus a negative b, right? So a minus b squared, let's think of it as a plus a negative b, the quantity a plus a negative b squared. Okay? And then you'll notice that you're going to be squaring the a's, you're going to be squaring the b's, and you're going to have a negative 2ab in the middle, twice the product of A and B. And notice, because you're multiplying a negative by a negative here, you're going to get a positive term there. Okay, let's look at some of those. Okay, here's our key concept first. We'll say this one more time. So we have, this is the square of a difference. The quantity a minus b squared. So we're going to think of that as a squared. We'll have a minus twice the product of a and b plus b squared. In numbers, let's look at x squared minus the quantity x minus 3 squared. So our x's are squared. The negative 3 times negative 3 is going to give us our 9, and twice the product of a and b. So 3 times 6 times 3x times 2 is going to give us a negative 6x. And that's the pattern you'll see with the square of a difference. Again, of course, you know a difference is the answer to subtract. It indicates a subtraction problem. So let's try this problem right here. Find 2x minus 5y squared. Of course, we're going to write our problem first. Squared. So that means we have 2x minus 5y times 2x minus 5y. You can think of it like that, right? Okay. So what do we have? We're going to, let me say this. Would this be helpful to have this here for you to think about? What is a minus b going to be? It's going to be a squared minus 2ab plus b squared. Okay? So therefore, Let's substitute in 2x minus 5y squared. We're going to approach this a little, think of this a little bit differently. So our a squared is going to be our 2x squared, right? Our negative 2ab is going to be negative 2 times 2x times 5y, right? Plus our b squared is going to be negative 5y squared. Okay? I should put that in parentheses, excuse me. All right, so what do we have here? We have 4x squared minus 2x times 5y is 10xy times negative 2 will be negative 20xy plus 25y squared. All right, did everybody see that? Let's see if we have another one maybe we could do. Well, here are two for you guys to do. So you're going to take 6p minus 1. And why don't you go ahead and do it this way? A squared minus 2ab plus b squared. And substitute in what we know. So if this is a minus b, right? Squared. So take your a squared, which will be 6p squared, right? Minus 2 times a times b. And so a is 6b, 6p, and times a negative 1, which is our b, and plus b squared, which is negative 1 squared. Okay, and see if you can go on from there. And then you guys try the next one. All right, the product of a square of a sum or the square of a difference is called a perfect square trinomial. So here's a definition for you. The product of the square of a sum or the square of a difference is called a perfect trinomial. And we're going to use that to look at a real world problem. Remember, when you're squaring, this is an easy mistake. A lot of people look at this and think, oh, x squared minus 49. They square the x, they square that. That is not the case. Okay? Make sure you follow the steps and look for the right patterns. Okay, let's look at a real world problem. Each edge of a cube of aluminum is 4 centimeters less. It is 4 centimeters less than each edge of a cube of copper. Write an equation to model the surface area of the aluminum cube. Okay, I'm going to underline some important things. Each edge of the cube of aluminum. So we have aluminum and we have copper. And they're cubes, right? Everybody knows what a cube is. It's a square in 3 dimensions. And it's 4 centimeters less. The aluminum is 4 centimeters less than the copper. And we might need to model an equation. We have to write an equation about the surface area. All right. So first thing I would do is I'd be drawing pictures. I'd be drawing a picture of a cube and of a little bit bigger cube. All right? And I know that one cube, each side is C. And I know another cube is C minus 4, right? Okay. Now, we have to find the surface area of the aluminum cube. Well, in case you don't know what the formula for the surface area of a cube is, it is SA, surface area, equals 6S squared. Easy enough? Okay, so let's see what that means. Let's see if I can get this away and extend our page a little bit. Bear with me just a second, guys. I guess maybe not. Okay, so what we're going to have to do is we'll take our 6S squared, which equals the surface area, okay? And we know we're finding the surface area of an aluminum cube. So it's the smaller cube. So we're going to be multiplying 6 times the length of its side. And we know the length of its side is c minus 4. And we're going to square that. Okay? So SA would equal 6, and c minus 4 squared is c squared minus 8c plus 16. Okay, remember a squared minus 2ab plus b squared for the difference of for the square of differences. All right? So then we multiply that out and we get 6c squared minus 48c plus 6 times 6 is 36, carry 3, 96. Or we just needed the expression, I think, so the book was really just looking for that. Okay, so that wasn't bad. Try your practice problem right here. We're getting there, guys. There's your practice problem. Pause the video and start it back up when you're done. All right, product of a sum and a difference. So what if we have a sum and a difference? What if we have a plus b and a minus b? Remember, a minus b can be written like that, a plus a negative b, okay? So when we have a sum, an addition, and a difference, we're going to see that we end up with that these two middle guys, a, b, are going to cancel each other out. Well, we'll watch and see how that happens. But so what you end up with is a squared minus b squared. Here, let me show you. Well, I'll rewrite what they've done down here so you can see it a little better. So we have a plus b times a plus b, right? That would be, oops, minus a plus b, my bad. Minus a minus b, all right? So if we multiply that out, we get 2, excuse me, we don't get 2. We get a squared plus ab minus ab minus b squared. All right? But look at these two guys cancel each other out, don't they? So we end up with a squared minus b squared. Okay. So when we have a sum and a difference, this is what we're going to get. All right, and this is basically what this key concept says. We've been over this pretty specifically. I'll let you copy this down in this slide. I'm really not going to say anything else about this. We have, I will say it, you know me. We have a plus b and a times a minus b. We have a sum and a difference. When you multiply those out, you get a squared minus b squared. And this just reminds you that a and b can be numbers, they can be variables, or they can be expressions with numbers and variables. So they'll look different in different questions. Okay, so here we have one. We have 2x squared plus 3 times 2x squared minus 3, all right? So our terms have gotten a little more complicated, but the process is exactly the same, right? We have a plus b times a minus b, okay? And that's going to equal to a squared minus b squared. Now let's substitute in what we have. So we have 2x squared plus 3 times 2x squared minus 3. So our answer is going to be a squared, 2x squared, right? Because our term is 2x squared, and we have to square that, so it's going to be 2x squared minus 3 squared. And if you simplify that, you'll get 4x to the 4th minus 9. All right? So take a minute. I think it's helpful to set the problem up by writing this out and then substituting in what we have. When you get better at it, you'll be able to skip the first step. But for now, I think that's probably pretty helpful to do. Here are your practice problems. And this is the end of the video. I kept it to 20 minutes. Oh, good. That's what I was hoping to do. All right, guys. Good luck with this. Talk to you tomorrow or Thursday.